Hey guys, and welcome back to Programming in Objective-C. I'm Yari Dareglia of Jump Zero, and in this second lesson I walk you through control structures. Control structures are statements used to manage the application flow. Today I show you how to check simple true-false conditions with the if-else statements, how to make more complex decisions with the switch statement, and how to perform iterations with the for and while loops. Those statements are inherited from C, so they are really similar to what you can find in many other languages, such as PHP or Java. So if you already know another language, you'll have a much easier time with this part. Okay, create a new command line tool project, as I've shown you in the first lesson. Now let's say we want to create a simple interface manager for a video game. The application will present game information such as the player life and the score. We can start by storing the player life data using an integer variable. So I can write int life equal to 100. Now we want the interface to show different messages depending on the current life value. So we can define output adding a condition. If life is greater than 50, the interface drops I'm OK. Else, the interface drops I need an healer. The first block of code is executed only if life is greater than 50. Otherwise, the second block will be executed. The else block is not required at all, so we can use an if without the else block in this way. It's also possible to chain an else with an if block in this way. Else if life equal to 0. Okay. So we could easily go through a much more complicated message list for the UI simply by adding more else-if blocks. To sum up, with this code you get I'm OK for value greater than 50, so from 51 up. Game over whenever life is equal to 0, and I need an healer from 1 to 50. Come back to our video game interface manager, and let's say we want to show messages depending on the player vehicle type. To describe the player vehicle data, we could use some aliases created with the define instruction, like define car, for example, equal to 0, define plane equal to 1, and define bike equal to 2. Now, for example, every time we write car in the code, it will be substituted by the preprocessor with the value 0. But before moving to the switch statement, let me introduce a better way to obtain the same definitions. We define the player vehicle type with a custom data type created with enum and typedef using this code. We create a set of named integer constants and assign a name to this set. In this case, player vehicle. With this definition, car is equal to 0 and automatically plane is equal to 1 and bike is equal to 2. So now we have a clearer data type to use in the application. Let's do it. We can create a player vehicle, for example, equal to car. We can now move on to the next statement, the switch. The switch controls complex conditions and branching operations, moving the application flow to the case whose expressions matches the switch value. So we are going to use the switch to draw the right interface depending on vehicle type. Now we use the player vehicle as expression and the vehicle types as cases. That said, our graphic user interface can draw different information depending on the current player vehicle. So from previous definition, we have car, plane, and at the end, bike. The application in this example will execute the code in this case, the first, because it matches the value of the variable player vehicle, so car is equal to car. The break instruction makes the application jump immediately to the end of the switch, skipping the other cases. When no matches are found, the default code is executed. So, needless to say, the switch is a powerful way to perform decisions in your application. The next step of statements are useful to create loops and repeat blocks of code. Let's start with the for loop. Let's say we want to create a countdown system for our graphic user interface. We can use a for from 0 to 10. This is a really common syntax, so I'm pretty sure that you have already found it in other languages. Anyway, first block of code is the init expression. A variable I with a counter role is defined here, setting the loop start at 0. The execution of the loop continues until the loop condition in the second block returns false. And the last block is used to decrease or increase the current value of I, the counter, at the end of every loop. Compiling this code, we obtain the countdown messages in the console. So, in the first loop, I is equal to 0, that is less than 10. The block of code is executed and the output is 10. At the end of the loop, the I will be incremented by 1. I is equal to 1, and again it is less than 10. The code will be executed for I equal to 1, so the output will be 9, and so on until I reaches 10. Another way to obtain the same result is using the while loop. Let's see. The while loop has a straightforward syntax. We use the while keyword, we specify a condition, and we write the code we need to loop over. So this is extremely simple. The while loop is executed until this condition is false. A little variation of the while loop uses the do statement in this way. You can select the while and put it at the end of the function and substitute it with the do. The difference between do while loop and while is that through the do while loop, the block of code is always executed at least once. The expression is in fact evaluated at the end of every loop. Okay guys, we are done for today. In the next lesson we'll have a look at pointers and memory, going deeper in the Objective-C programming. Bye and thanks for watching.